Okay, the last talk of the grantee is going to be given by Steven from Princeton. And he's going to tell us how we're going to move from reverse engineering online, reverse engineering online tracking from, a research prototype field to things that actual user can use, which is a very good, topic for us to discuss today. So looking forward to it.
Thank you. So I'm Steven Englehardt from Princeton University, and I'm going to talk to you about our work on reverse engineering online tracking and what we're doing to make this work easier. So third-party tracking basically exists because when you're browsing the web, if you visit a party, like if you visit a site, you're not just visiting that first party, right? You're visiting all the third parties who are included in this. And each of these third parties may be setting cookies. Those cookies, thank you. Those cookies may have identifying values in them. And then as you visit different first parties, the same cookies are sent back. So the third party knows that it's you who's visiting them. And if I'm a tracker and I want to track people across all the sites, then what do I do when the user deletes cookies? If cookies are the only thing that I have, I'm going to lose all the history that I had on this user before, and I'm going to start a new profile. And I won't actually know that it's the same user unless I use some outside information. So that actually led to trackers using things like ever cookies. And ever cookies, if you're not familiar, are basically the idea of we'll take that unique identifier that we used to place in HTTP cookies, and we'll put it in all different parts of the browser. We might put it, for example, in flash storage. So if the user clears their HTTP cookies, we can grab it out of the flash storage and respawn it. And this actually led to Ed Felton, a security professor at Princeton, saying in 2009, if you're going to track me, please use cookies, because at least we can manage cookies, and I can't manage the state in this other location. But actually, browser manufacturers responded to this, and they made it possible to clear cookies in Flash. They made it possible to clear browser state in all of these other locations. So things were actually getting better again. But then trackers said, well, we need to keep tracking people even if they clear those locations. So Panopticlick came out in 2010 from the EFF. And this is basically about browser fingerprinting. So instead of storing an ID in the browser itself, what we'll do is we'll look at the browser's properties. And actually, surprisingly, those properties are enough very often to identify the browser uniquely. And I'll just give you an example of something I worked on measuring, which is canvas fingerprinting. So here, a JavaScript file can write some text, scale it differently, give it different colors, and so on, to the HTML5 canvas. In the background, you wouldn't actually see this image. And then they can read it back and hash that. And based on the video card of the machine, how this text is going to be rendered and anti-aliased and so on, very, very many factors. It will be the same for your machine every time, but it will likely be different between machines. So fingerprinting can help bridge that gap, or bridge the gap if the user clears their browser state. So I think we need to update our statement from 2009 to say something like, if you're going to track me, well, please at least use browser storage, because I can't really change my browser's fingerprint. So that's kind of the state of things for a couple years, but now we have the problem of people are using desktop browsers and mobile browsers. And if I'm a tracking company, now I have a big problem because half of the users' browsing history is on desktop and half the browsing history is on mobile. And what am I going to do to link that profile together? But there are solutions for that too. So maybe we'll just have the desktop browser play some sound, and maybe we'll have that sound be outside the audible range of what the user sitting at the desktop would actually hear. And then we'll use the microphone from the smartphone and listen for that sound. And if we hear both of these happening enough times, we can make the inference that it's likely that the owner of the smartphone is the owner of that desktop. And actually, this is known as cross-device tracking. The FTC is having a workshop on this today, so I'm glad to see this getting some coverage and being discussed. But it means that we need to update this quote again to say, if you're going to track me, well, please at least limit it to one device, because then maybe I can use devices to separate my online identities. But my point here is, what are we going to be asking in 2020? And I think the work that we do at this conference and the work that we're all working on can help change that statement. And I think measurement can help, and this is actually what I've been working on. So loosely defined, measurement is, in my opinion, taking a browser that's been automated and going out and visiting a bunch of different sites with it. So for example, I might use Firefox to visit New York Times, eBay, and Fox News, and see what those sites do when I visit them. Are they trying to fingerprint me? What cookies are they setting? What storage locations are they using? But web measurement is not without its hurdles, right? We see a lot of studies having a significant amount of engineering debt and spending a lot of time building the platform just to do the study. So in 2014, we went and looked at 33 different studies. I don't really expect you to see anything here, so I'll highlight a couple of the useful points. There were a bunch of studies on this and a bunch of different platforms. We saw several studies using Selenium, which is a full browser automation tool, lets you drive like Chrome or Firefox and visit sites with it. We also saw a couple using Phantom.js and Casper.js, which is a headless WebKit version. And then for instrumentation, for recording what the browser is doing when you visit it, we saw a bunch of people using Fourth Party. Fourth Party is a tool out of Stanford that basically will record access to some JavaScript APIs, particularly the type of fingerprinting that Panopticlick, which I mentioned before, does, or shows how that's possible. And we also saw a bunch using proxies, various proxies. So I think the point to highlight here, though, is that Fourth Party is really the main piece of shared code between all of these studies. So the second thing is having a lasting impact. So oftentimes there'll be one study that's done by a group, maybe they'll publish it in a research conference, and then the question is what happens a year later, 2 years later, and so on. And you might hope that someone does a follow-up study, but that might not always happen. So I want to highlight one example here for canvas fingerprinting. I was involved in this study in 2014, and we saw that this canvas fingerprinting was happening on 5% of the top 100,000 sites. We were able to do that, again, by looking at these JavaScript calls. Basically, if we saw sites doing that, we suspected that they were doing canvas fingerprinting, and we were able to check out the actual JavaScript files to confirm that. But I went and reran that last month, and I saw that although it's come down significantly, there are still first-party domains doing this, over 100 on the top 100,000. And some of the first parties even have two third parties doing canvas fingerprinting, which is what you see here, a visualization of both of them. So it's still going on. It would be nice to know on an updated basis who's doing these things. So I think there are two ways to overcome these hurdles. And the first is through a common platform. So we don't have to re-engineer web measurement platforms every time we want to do a study. And the second is a web privacy census. And that I'm going to talk about in a couple moments. So to build a common platform, we've been working on OpenWPM. So it does use Selenium, like many other web studies before us, to drive Firefox. And we have Firefox communicate through Minim proxy with the website. So we can capture all the HTTP requests, all the HTTPS requests, and know what's going on outside the browser, but between the browser and the web. And then we added in fourth-party style instrumentation. So fourth party, like I said, is a Firefox extension. So we've basically taken that, took all the fourth-party code and built on top of it, added some new things to it, and integrated it into the rest of this platform. We give the researcher access to all of these things in a modular way. So if you want to write code and stick it into the extension, you can do that. You can stick it into the proxy. You can write code to interact with the automation platform, or Selenium. And then we wrapped all of this in what we're calling a browser instance. But if you ever tried to crawl a lot of sites with Selenium, you've probably seen that it tends to stall, or you tend to get blocked on something, and your crawl will kind of come to a stop, and you have to do something to fix that. So we've isolated it in its own process and built a manager, which we're calling the task manager, for that. So you can run with any number of Firefox instances that you want, as many as your machine can support, and each of those will have its own proxy and will have its own version of the extension and so on to do measurement. And then we aggregate all of that into the same database, so you don't have to try to do that after the crawl. So a few other points is we want to support state. We want to be able to do crawls that you keep the same cookies every time you visit a new site. We want that to be consistent, even if the browser freezes or crashes. We don't want that to corrupt the data for the study. And like I said, we're using Firefox for a reason. We want to be able to test extensions, for example. How well does Ghostery fix the problems that we're studying? We want to be able to test the browser's own privacy features, as well as have support for all of the new APIs that are coming out. For example, Phantom.js may not fully support WebGL, HTML5 audio and video, but having a real browser, you'll have support for that. And so with that, we want to do a web privacy census. We have been, since June this year, running a 1 million site crawl every month. So this is, this is basically Firefox going and visiting 1 million sites and collecting JavaScript calls that we suspect might be used for fingerprinting, collecting all the JavaScript files that we see on all of those sites, the HTTPS requests and responses, as well as the storage locations in the browser, such as cookies or Flash. And in addition to this large crawl, we're doing a couple smaller targeted crawls. For example, stateful ones where we do keep the same cookies with each page visit can let us look at things like, are people respawning cookies with Flash? Are people doing cookie syncing, which is 2 third parties sharing their identifiers that they have for you? And we can also do stateless crawls of things like Ghostery, AdBlock Plus, HTTPS everywhere. Or, for example, Firefox's tracking protection. We can test that as well and see how well it's doing. So the census will let us do things like measure how effective these tools are, quickly deploy new measurements. Maybe if we see a new fingerprinting API, we can easily wrap that into the next month's crawl. And also release the data from this and the analysis monthly. So maybe that can be built into, can be built into other studies, or can be built into, say, consumer-facing tools about how much tracking is going on each first party. So I want to tell you a story about Webrtc local IP sniffing. So I'm not sure if everyone's familiar with this, but the Webrtc can be used to sniff the local IP of your machine from JavaScript. So typically if you contact a third party, they're going to get your public IP. That makes sense. But for example, for a home user, the third party can also get something like 192.168.1.2, right? Your local IP on your network, which might not be so identifying because most people probably have the same IPs. But if you're on a corporate network or a university network, that might actually be kind of unique and different than your public IP. So I saw a tweet that the New York Times was doing this and using it, and I said, well, why don't we go and measure that in our larger crawls? So I added some JavaScript instrumentation to do this. And I want to point out, this was added to the Firefox extension that I was talking about. We only needed to add one line to do this. Just call our instrument prototype function, which can instrument any JavaScript object prototype, and call it on the API that we see being used for fingerprinting. And this is the kind of thing that we want to support, right? We want to be able to think of a new thing to measure and just pop it into a pre-existing platform rather than having to build a new platform to write a study to measure this. While the crawl was running, I wrote some analysis code. Essentially, if you want to do the IP, if you want to grab the local IP, you need to use a couple of these methods. So we wanted to see who was using that. And then I was able to check the JavaScript files that we saved to confirm that it was actually happening. So just last month again, I saw that on the top 100,000, there are 121 first-party sites doing this. 29 of them are in the top 10,000 sites, and there's 24 unique parties. And it's important to note that when we check all of these requests against the AdBlock Plus list, only one of them shows up, the easy list and the easy privacy list. So these are things that, even if you're browsing with current blocking tools and trying to protect yourself, this will still happen. So with regular measurement, we can inform the public. We can use this data to build block lists, right? And we can change the incentives so that perhaps in 2020, we can say something like, if you're going to track me, I'm going to know about it, and maybe I can do something about it. So if you want to help us make the web more private, you can check out our GitHub repo, contribute code, pull requests. All the studies that I do, I try to do, any changes I make to OpenWPM, I try to do in public. So you have the newest version, you have what we're using. And if you want to collaborate, feel free to check out our research page and you can find our contact info there. So thank you, and if you have any questions.
Thank you. There's one here.
I moved. In seeing all the work you're doing, does it make sense to have like a website where there's a good housekeeping seal on sites that are using good practice, and especially those that are not using good practice, and promoting that, and having a seal that companies would be willing or would be qualified to put onto their site, and then people would recognize it? Is there some kind of direction there at all to make it more proactive?
Yeah, so one of the ways we were thinking to have that effect would be if we release the tracking data, like who's using certain types of fingerprinting APIs by the first party or by the third party, then someone could build an extension that says, hey, you're visiting this first party, and they've been seen to do these various things. So we could bring awareness by the first party or by the third party right in front of the user's eyes, kind of like Ghostery does. Yeah.
If you don't see a seal, if you don't go to that site,
Yeah.
or you're aware that that site doesn't.
Yeah, exactly. I think that could be another way to do it, through a seal.
I think there's one here.
Yeah, so this is very, very cool. But I mean, one thing that surprised me, at least at some level, is that actually for a couple of these, very, very few websites are doing it. I mean, you talked about numbers like 1 in 1,000.
Yeah.
And you know, you're using the top 100,000 or top 10,000. I suppose if you narrowed that down to the top 1,000 or something, you get nothing, right, in many cases. So, I mean, there's sort of good news there, right, is that for most of us that just visit pretty common websites, we're probably not going to see this. Yeah. Certainly, these more advanced, I guess you could call them, like fingerprinting measures, we haven't often seen them on the top sites. We did for the May 2014 study that I mentioned, when it was on 5% of the top 100,000. But since that went away, we're not seeing like canvas fingerprinting on that. But I guess it's important to note that we can keep, like, by measuring it, we can keep it low, hopefully. Yeah. No,
Exactly.
I think that's great, but I mean, there's sort of good news in this, is that at least for some of this really weird stuff, it's not happening much. What kind of sites are these, you know, these 100 or a few hundred that do this? What?
I should have mentioned this. Oh, you mean the 100 that are in here?
If, for instance. I mean,
Yeah, it just happens to be like random sites. Some of them are sites you might visit. Like some of them are big news publications or things like that. But it tends to be kind of a random assortment, at least from what I've seen.
Actually, I had a question. Do you have any idea of the dynamics of this thing? Because I imagine, you know, there's a new tool, maybe the new super fingerprinting, and then people get crazy, start deploying it, and then, you know, there's a big press release, and then people remove it. But of course, the web is a big story of everything, so you will always have a site that forgot to update, or that is just slow to get it. So do you have any idea of that?
So yeah, I think that's actually what happens very often with these fingerprinting methods, that basically there will be some sites who are still using it and who just never turn it off. And very often it's the first party site, right? It's not being provided by a third party, but it's some first party fingerprint script maybe before the user logs in. It's important to say that I think cookie respawning actually ended up in a couple lawsuits. So surprisingly, when we did measurements of that in 2014, we didn't find it, and these were lawsuits in the US, we didn't find it on any US site, but we found it on a bunch of Russian sites and sites outside the US.
Okay.
So I guess the US sites all stopped doing it once there were some lawsuits involved.
Yes, there's a question over there. Actually, two. Can you bring the mic over there to Mark? Yes. And then there's a second mic. Yes.
Is there any concern that doing this, because it sounds like what you were saying before, there's been kind of like, well, we made a rule against this, so now the site started doing something else. We made a rule against this, and now they started doing something else. So is there any concern that as the measurement process gets faster, that it'll just amp up the arms race, I guess, in terms of like thinking of new techniques?
Yeah, that is definitely a possibility. I could see that happening. And I think as long as third-party scripts tend to come, as long as third parties don't start splitting their scripts up, it can be pretty easy to detect new things by just seeing what else is happening in the script, like after a third-party script changes. But then you can imagine an arms race again, with that, where I'm going to deploy a new fingerprinting method, but I'm going to put it in a different script so you don't connect it with my old methods. So I could see this happening, but I think there are only so many things you can do in terms of fingerprinting, for example, that hopefully we can catch them all and measure them all.
One last question.
It's my assumption that the first parties aren't really engaging in much fingerprinting of this sort, but that might not be accurate, but it's sort of nefarious or not so nefarious third parties. Is it your sense that the first parties, that the websites that people are visiting, do they know what's going on?
So, yeah, that's a good question. When we released the results from that 2014 Canvas study, we actually got emails from first parties saying, hey, we didn't know this was going on. We've removed that third party from our site. Can you please redact us from your paper or from your results? So we added a disclaimer, right, saying that this was May 2014. It may not be the same anymore. But we've seen that happen, where first parties don't know.
I have a promise that this is a short question.
Short. So we used to be able, there was a while ago it came out that we could track MAC addresses walking through a mall, and then there was some apps that came out that allowed you to poison the tracker's database by mirroring MACs. Is there some way that now that we know that this fingerprinting method is available, that it would just be equally as easy on that crawl to poison the tracker's database? Like if individuals, I don't think we need to do that, but if individuals wanted to, could we do that?
So there have been a couple of studies looking at, how we can lie, and actually one of them is Prevaricator by Nick. He's here in this audience. So it's basically, can we lie when we're visiting these sites, and can we lie in a way that doesn't affect real uses of the API, but will affect the uniqueness or the identifiability. So that could be possible. I think the study was pretty promising, but I haven't done any work in that area myself.